All right, so I'm going to go over problem 4 from the 2023 AP Stats free response section. So again, these are going to be my solutions. The official solutions are not going to be out for a few months, probably June or July. So just let me know if I make a mistake or if you notice something, iffy, and I'll try to, address it. So just leave that in the comment section. Okay, so problem 4, we got that a medical researcher completed a study comparing an omega-3 fatty acid supplement to placebo in the treatment of irritability in patients with a certain medical condition. 19 patients with a medical condition volunteered to participate in the study. The study was conducted using the following weekly schedule. Week 1, each patient took a randomly assigned treatment, the omega-3 supplement, or a placebo. Week 2, the patients did not take either the omega-3 supplement or the placebo. This was necessary to reduce the possibility of any carryover effect from the assigned treatment taken during week 1. In week 3, each patient took the treatment, omega-3 supplement, or placebo that they did not take during week 1. So if they took the omega-3 during week 1, then that means they would have taken the placebo during week 3 and vice versa. At the end of week 1 and week 3, each patient's irritability was given a score on a scale of 0 to 10, with 0 representing no irritability and 10 representing the highest level of irritability. For each patient, the 2 irritability scores and the difference in their scores, placebo minus omega-3, were recorded. The results are summarized in the table and box plots. Okay, so here we got the data on the sample of all these volunteers showing what their mean irritability scores were when they took the placebo, the omega-3, and the difference. Placebo score minus the omega-3 score, along with their standard deviations. And here are their box plots. And here's the box plot for the difference in the irritability score. Okay, now parts. Well, not part, but the rest of the question is asking for that the medical researcher claims the omega-3 supplements will decrease the mean irritability score of all patients with a medical condition similar to the volunteers who participated in the study. Is there convincing statistical evidence to support the researcher's claim at a significance level of alpha equals 0.05? Complete the appropriate inference procedure to support your answer. Okay, so let's first go over this. We have, three statistics in general. Well, we have more when we have 6, I guess, but we're looking at three sets of the sample data, I guess. So we have the mean for the placebo, the mean for the omega-3, and the mean for the differences. Now, don't mix this up with a 2-sample test for difference in means. That's a key thing you want, I think, that they're trying to get you on this problem, because you want to basically see if the omega-3 is going to reduce the irritability score. So these two are necessary. These 2 sets of data are necessary to get this. But this is really the one you care about, because this is what you're trying to study. This is just what is necessary to get a difference. Like, you're not going to be able to get a difference unless you take a score with a placebo and a score with an omega, and then subtracting them and then calculating these values. So it's really just a 1-sample t-test for means, but mention that it's paired data, or it's a matched pairs test for difference in means, or actually no, for difference in means, depending on how you word it. You basically want to make sure that you what I'm going to guess that they're trying to make sure that you mention is 1-sample t-test for paired data, matched pairs, that sort of thing. That's the main thing they want with the test. And then you can go ahead and then we mention what our null hypothesis and alternative. The null hypothesis is that there is no difference in the mean difference versus the alternative is that the mean difference is greater than 0. Because we want it to be greater than 0 because since we're doing placebo minus omega, we want to show that the placebo score is going to be greater than the omega score. Because remember, the higher score means it's a higher level of irritability. So we want the omega-3 score to be lower than a placebo. So their difference has to be greater than 0 for the alternative. And again, and you don't have to put this in the first part of your problem, but you're going to want to mention that we're talking about the population of old patients with a medical condition similar to those in the study. Because you can't just apply this to every person in the population because these are volunteers. These are volunteers, so you can't apply this to, again, the general population. All you can really do is apply it to individuals similar to those in the study. Next, I ran our conditions to make sure we checked it. Random assignment. It's not going to be a random sample, or it's not random selection. It's not random selection because these are volunteers, but random assignment will be, within the experiment. The independence condition. Our sample is 19, and so it's safe to say that this is going to be no more than 10% of the population of all, all patients with medical conditions similar to these volunteers. So capital N is population. Normal large sample. Now, our sample size is only 19, so it's less than our boundary level of 30. So since we don't have a sample size of at least 30, that just means we got to make sure we inspect the sample data and make sure that you address that there's no extreme skewness or outliers in the data. And so looking at it, it looks, pretty okay. There's nothing, no real big issues, no crazy skewness, no outliers. So then it's okay to proceed with this t-test. And you run the t-test, and you'll get a p-value of about 0.0284. Now you can run this in your calculator, which I advise you to. So if you go to your stats function, go to test, just go to t-test, and you're gonna go to stats. Use stats, don't do data because we don't have all the individual values. Our null hypothesis will be 0. Our sample mean was the 1.789. Standard deviation was the 2.485. Sample size is 19. And again, we're doing a one-sided test for the mean difference being greater than 0. Whoops, let me just go to calculate, and this will give you your p-value. So this is pretty low. This is 0.02%, or 0.2%, or just put 0.00284. And since this is less than our alpha level of 0.05, which says right there, that means that we have, pardon, I try to squeeze that all in there. Since our alpha level is, greater than our p-value, or our p-value is less than our alpha level, then we can reject our null hypothesis because we have statistically significant evidence to say that the true mean difference between the, irritability scores, or mu sub d, we can say it's greater than 0. And then in context, that's basically saying that we have convincing evidence to claim that the omega-3 supplement does in fact reduce irritability scores for the patients similar to those in this study. All right, so there you go. I hope this helps. But again, let me know if you have any questions in the comment section.